Chapter 3.2, the remainder theorem. Let's review long division, which we first saw in our rationals unit. If we divide a polynomial, p of x, which is called the dividend, by d of x, which is called the divisor, then the result is q of x, which is called the quotient, plus r, which is the remainder, divided by d of x, which again is our divisor. Our divisor is going to be a linear binomial. So we can also write this as p of x over x minus a linear binomial, is equal to q of x plus r over x minus a. Note, if there is a missing term, for example, if we have an x cubed term, but we don't have an x squared term, we need to include the missing term with a 0 coefficient. Example, divide p of x equals 2x to the 3 minus 3x squared plus 4x plus 5 by d of x equals x plus 2. We start by setting up the division problem. We have x plus 2, that's our long division symbol, 2x to the 3 minus 3x squared plus 4x plus 5. Next, we look at the first term in the dividend, which is 2x to the power of 3, and we divide that by the first term in our divisor, which is x. 2x to the 3 divided by x gives us 2x squared, and then that goes on the top of our division problem. Next, we multiply our divisor, x plus 2, by the term we just calculated in the step above, so by 2x squared, and x plus 2 times 2x squared gives us 2x to the power of 3 plus 4x squared. We write this product below the first two terms in our dividend, and then we subtract 2x to the 3 minus 2x to the 3. That first term should always be 0 when we're doing this, and then negative 3x squared minus 4x squared gives us negative 7x squared. And then we basically repeat the process. So we bring down our next term from our dividend, which is 4x. Then we look at the first term in this polynomial that we have here, so negative 7x squared. We divide that by the first term in our divisor, which is x, and we get negative 7x. Then that number goes as part of our quotient, and we multiply x plus 2, our divisor, by negative 7x, which gives us negative 7x squared minus 14x. We write that binomial here, and then we subtract. Again, the first term should always be 0. Negative 7x squared minus negative 7x squared would be negative 7x squared plus 7x squared, which is 0. Then we have 4x minus negative 14x, which would be 4x plus 14x, which would give us 18x. And then we carry down our next term. So we have a binomial 18x plus 5. We look at our first term in that binomial, 18x. We divide it by the first term in our divisor, which is x, we get 18. We put that term as the next term in our quotient. Then we multiply x plus 2 by 18. We get 18x plus 36. We put that binomial here, and then we subtract. 18x minus 18x is 0. That first term again needs to always be 0. 5 minus 36 is negative 31. We no longer have an x term here, and we also don't have any more terms to carry down. So we know that we're done because we can't divide this constant term by this binomial x plus 2. Then our solution, 2x to the power of 3 minus 3x squared plus 4x plus 5 divided by x plus 2 gives us the quotient, 2x squared minus 7x plus 18, plus the remainder of negative 31 divided by our divisor of x plus 2. So this is our q of x, which is our quotient. This is our remainder. And this is our divisor. Divide p of x equals 2x to the 3 plus 3x squared minus 4 by d of x equals x minus 1, expressed in the form p of x over x minus a equals q of x plus r over x minus a. Let's set up our division problem. My divisor is x minus 1. My dividend is 2x to the 3 plus 3x squared. We don't have an x term, but we need to write an x term. So plus 0x minus 4. You always need to include any missing term with a 0 coefficient. Looking at the first term in the dividend, 2x to the power of 3, if we divide that by x, we get 2x squared. That becomes the first term in our quotient, 2x squared. Next, we multiply 2x squared and x minus 1 and write our answer below the first two terms of the dividend. 2x to the 2 times x is 2x to the 3. 2x to the 2 times negative 1 is negative 2x to the 2. And then we subtract these two terms from the first two terms of our dividend. The first difference needs to equal 0. 2x3 minus 2x3, that's 0. The second one, 3x squared minus negative 2x squared, so that'd be 3x squared plus 2x squared is 5x squared. Then we want to bring down the next term, 5x squared plus 0x, and then start our process again. Looking at the first term in this binomial, 5x squared plus 0x, so 5x squared. When we divide that by x, what are we left with? We would have 5x, so that becomes the next term in our quotient, plus 5x. Then we multiply that term by our divisor, x minus 1, and we write our answer below. We get 5x squared, and then 5x times negative 1 is negative 5x. Now we subtract. Again, first term needs to equal 0. 5x squared minus 5x squared, that's 0. 0x minus negative 5x, that would be 0x plus 5x, so we get 5x. Then bring down our last term, so we have 5x minus 4. And repeat our process. If we look at our first term in this binomial, 5x minus 4, so 5x, divide that by the first term in our divisor, which is x, we get 5. That becomes the next term in our quotient, so plus 5. If we multiply that term by our divisor, so 5 times x minus 1, we then get 5x minus 5. Then we subtract 5x minus 5x is 0. Negative 4 minus negative 5, which is negative 4 plus 5, which is 1. And then we can't continue on because there's nothing more to carry down, and we can't divide the constant term 1 by the binomial x minus 1. So we have, this is our quotient, and 1 is our remainder. And if we write our answer in the form q of x plus r over x minus a, we have p of x, which was 2x to the 3 plus 3x squared minus 4, divided by x minus a, which is x minus 1 in this case, is equal to our quotient, 2x squared plus 5x plus 5, plus our remainder, which is 1 divided by our divisor, x minus 1. Synthetic division. This is another method of doing long division. For synthetic division, write only the coefficients of the variables in descending order of degree, including a 0 coefficient for any missing variables. Then we're going to draw an L around our numbers, write the sign and the a value from the divisor on the outside of the L, bring down the first number outside the box, then we multiply outside the box and subtract inside the box. And then we write out our answer starting on the right side as a remainder. Next term would be a constant, and working our way left, increasing each x exponent. Let's give it a try. Solve x to the power of 3 plus 7x squared minus 3x plus 4 divided by x minus 2. We write the coefficients of each of our terms. So 1 for x to the 3. Then we have 7 for 7x squared. Then we have negative 3 for negative 3x. And then we have 4. We draw an L shape and leave some space below the numbers. And we put the sign and the a value from our divisor on the outside. So since our divisor was x minus 2 in this case, then I'm going to write minus 2 on the outside here. So negative 2. We drop down the first term, and then with our number that's on the outside left and our numbers that are below, we're going to multiply. So negative 2 times 1 is negative 2. We write that here. And then we're going to subtract inside. 7 minus negative 2 is 7 plus 2, which is 9. Then again we multiply. Negative 2 times 9 is negative 18. And inside we subtract. Negative 3 minus negative 18 is negative 3 plus 18, which is 15. Multiply outside. Negative 2 times 15 is negative 30. Subtract inside. 4 minus negative 30 is 4 plus 30, which is 34. Then starting on the right, that first term becomes our remainder. Second term is our constant. Next term to the left is our x term, and then we have an x squared term in this case. So our solution is, our quotient would be 1x squared plus 9x plus 15, and then plus our remainder, 34, divided by our divisor, x minus 2. Try another one, 3x to the power of 3 minus 8x minus 1 divided by x plus 2. Write our coefficients down. So we have 3 for 3x to the 3. We don't have an x squared term, so we need to put a 0 in for the x squared term. Then we have negative 8 for negative 8x, and then we have negative 1. Draw our L shape, leave a little bit of space below the coefficients. Our divisor is x plus 2, so we take the sign and the a value, so plus 2, write that to the left of our L shape. We drop down our first coefficient, we multiply outside. Two times 3 is 6, and we subtract inside. 0 minus 6 is negative 6. Multiply outside. 2 times negative 6, negative 12. Subtract inside. Negative 8 minus negative 12 would be negative 8 plus 12, which is positive 4. Multiply outside. 2 times 4 is 8. Subtract inside. Negative 1 minus 8 is negative 9. Then starting on the right-hand side, first term is our remainder, then our constant, then our x term, then our x squared term, and so on if we had any more. So we can write our solution as 3x squared minus 6x plus 4, and then minus 9 over x plus 2. The volume of a rectangular prism is given by v of x equals x to the 3 plus 3x squared minus 36x plus 32. Determine possible measures for w and h in terms of x if the length L is x minus 4. We know that volume of a rectangular prism is length times width times height. If we divide both sides by the length, then we would get the volume divided by the length is equal to the width times the height. So let's divide our polynomial representing the volume by the binomial representing the length. We can do this with long division or synthetic division. You need to know both methods. I'm going to do synthetic division here. I write my coefficients. We have 1 for the x cubed term, 3 for the x squared term, negative 36 for the x term, and then 32 for the constant. Draw my L shape. Our divisor is x minus 4, so I'm writing minus 4 on the outside of the L shape. Dropping down that first coefficient, and then multiplying. Negative 4 times 1 is negative 4. Then we subtract inside. 3 minus negative 4 is 3 plus 4, which is 7. 7 times negative 4 is negative 28. Subtract inside. Negative 36 minus negative 28 is negative 36 plus 28, which is negative 8. Multiply outside. Negative 4 times negative 8 is positive 32. Subtract inside. 32 minus 32 is 0. Starting on the right, we have our first term is our remainder, then our constant, then our x term, then our x squared term. So the polynomial we're left with would be 1x squared plus 7x minus 8, and there's no remainder. This trinomial represents width times height. We said over here that if we divide the volume by the length, then we're left with width times height. And this is what we did here. We divided the volume by the length. So we have width times height equals x squared plus 7x minus 8. Let's solve this. We can factor this. We get width times height equals x, two numbers that multiply to -8 and add to 7 would be +8 and -1. Therefore, our possible measures for width and height are x plus 8 and x minus 1. The remainder theorem states that when a polynomial p of x is divided by a binomial x minus a, and the remainder is a constant, the remainder is the value of p of a. So when you plug in the a value into the polynomial p of x, so you put in whatever a equals for x, and you calculate, that value that you get is the remainder when you divide p of x by x minus a. Let's look at some examples. Use synthetic division to determine the remainder of p of x equals 2x to the 3 minus x squared minus 4x minus 4 divided by x plus 3. Our coefficients are 2 for the 2x to the 3 term, then minus 1 for the minus x squared term, then minus 4 for the minus 4x term, and then minus 4 for the constant. Draw our L shape. We're dividing by x plus 3, so we put plus 3 on the outside. We drop down our first coefficient, and then we're going to multiply outside. 3 times 2 is 6. We write that here. And we subtract inside. -1 minus 6 is -7. 3 times -7 is -21. We subtract inside. -4 minus -21, which is -4, plus 21, which is 17. 17 times 3 is 51. We subtract inside. -4 minus 51 is -55. So then we have -55 is our remainder. Next it says to determine the value of p of -3. So looking at our general term of the divisor is x minus a. Then the a value is the opposite sign of what it looks like in the binomial. So in our example, we have x plus 3. If we write that with a minus, it's x minus -3. So our a value is -3. Let's plug that into p of x. We have p of -3 equals 2 times -3 to the power of 3 minus -3 squared minus 4 times -3 minus 4, which gives us 2 times -27 minus -3 squared is +9. Minus 4 times -3 is +12 minus 4. 2 times -27 is -54. -9 plus 12 is +3, and then minus 4. -54 plus 3 would be -51 minus 4, which gives us -55, which was our remainder. So the remainder theorem allows us to determine what the remainder would be without having to actually use long division or synthetic division. use the remainder theorem to determine the remainder when x to the 3 plus 2x to the 2 minus 3x minus 1 is divided by x minus 1. First, we need to determine our a value. In x minus 1, our a value would equal 1. Then we plug that into p, so p of 1 equals 1 to the power of 3 plus 2 times 1 squared minus 3 times 1 minus 1, which gives us 1 plus 2 minus 3 minus 1. 1 minus 1, add to 0, 2 minus 3 is negative 1, telling us that our remainder, when we divide p of x by x minus 1, is negative 1. We can double check this by doing long division or synthetic division. So let's just do a check. Synthetic division, my coefficients are 1 for the x cubed term, 2 for the x squared term, negative 3 for the x term, and negative 1 for the constant. Draw my L shape. My binomial is x minus 1, so here I put minus 1. I don't just put the a value, I put the sign that's in the binomial and the a value. I drop down my coefficient and then I multiply. Negative 1 times 1 is negative 1. Subtract inside. 2 minus negative 1 is 2 plus 1, which is 3. Multiply negative 1 times 3 is negative 3. Subtract inside. Negative 3 minus negative 3, which is negative 3 plus 3, which is 0. Multiply negative 1 times 0 is 0. Negative 1 minus 0 is negative 1, which is our remainder. So yes, we got a remainder of negative 1 by using the remainder theorem, and then we checked it and saw that it was correct using synthetic division. Last example, what is the remainder when 11x minus 4x to the power of 4 minus 7 is divided by x minus 3? Using the remainder theorem, our divisor x minus 3 means we have an a value equal to 3. Let's calculate what p of 3 gives us. We have 11 times 3 minus 4 times 3 to the power of 4 minus 7, which is 33 minus 4 times 81 minus 7, which is 33 minus negative 4 times 81 is negative 324, and then minus 7. 33 minus 324 minus 7 is negative 298, which according to the remainder theorem would be our remainder. And just to make sure, let's check it using synthetic division. Our coefficients, they have to be in order of highest degree. So the negative 4 would go first for the negative 4x to the 4 term. Then we don't have an x to the 3 term, so that'd be 0. We don't have an x to the 2 term, that would be 0. Our x term is 11x, and then our constant is negative 7. Draw our L shape. Our divisor is x minus 3. When we do synthetic division, we put the sign and the a value, so minus 3. Drop down our first coefficient, negative 4. Multiply. Negative 3 times negative 4 is positive 12. Subtract inside. 0 minus 12 is negative 12. Multiply negative 3 times negative 12 gives us positive 36. Subtract inside gives us negative 36. Multiply negative 3 times negative 36 gives us 108. subtract 11 minus 108 gives us negative 97. And then negative 3 times negative 97 is 291. Subtract negative 7 minus 291 gives us negative 298, which is our remainder. So again, we can see that the number we got for the remainder using the remainder theorem is the same as the number we got for the remainder using synthetic division. That brings us to the end of Chapter 3, Lesson 2.